Alright, so now that we have that final velocity for that first second, we can solve our delta x using equation number 4. So Vf squared plus V naught squared divided by 2a. We plug that in, we get 7.75 meters per second squared plus 0, so I'll leave that off, and then put 2 times 7.75 meters per second. Oh, but that's not squared. That's just velocity. This one's squared. Alright, we plug that in, and there are different ways we could have used a different equation here for delta x, since we had both of these. But this is just one way of doing it. So we get 3.875 meters. Alright, so the second one, we want to find how far it went in this second second. So once again, we have a 1 second interval here, but we're not going to have a 0 initial velocity. So that's what's going to change. We're going to use the same equation right here. We have the same acceleration, but we're going to plug in the final for that second is the same thing, V naught plus AT, but that V naught is at 1 second now. And so we can say, we know it's 7.75 meters per second plus our acceleration, 7.75 meters per second squared. And our time interval is just 1 second again. We plug that in, and our final velocity at the end of our second is just that plus that. So 15.5 meters per second. Okay, so we can, let me do a different one here. So we can say delta x is 1/2, because we have a constant acceleration, V naught plus Vf, all times the time interval. So we can say 1/2. V naught in this case would be V naught 1, because we're starting at that first second interval. So 7.75 meters per second plus our second one, 15.5 meters per second. And that's over a time interval of 1 second. So times 1 second. If you plug that in, we get a displacement of 11.625 meters. Alright, so that one and that one are answers. And like I said, once you get those final velocities, you can solve it using this one, you can solve it using this one. Pretty much once you have that fourth piece of information, you can use whatever one you want. Alright, and so that's number 4.